NVN architectures. We are in an era of modern computer architecture which delivers high performance capability as opposed to the conventional von Neumann model. There is a shift from sequential machine or single processor, which is typically based on von Neumann, to multiprocessor systems that focuses on concurrent processing, which are typically based on non-von Neumann or NVN. The NVN architecture involves two or more interconnected processes to perform concurrent processing of instructions or data. Classification of some computers based on NVN. Vector computer. A vector computer has an instruction set that comprises vector as well as scalar operations, in contrast to von Neumann computer that supports only scalar operations. 2. Array processor. A processor that uses pipelining to manipulate vectors, but without utilizing vector instructions, and provides a low-cost alternative to a vector computer. 3. Associative processor. A processor with an associative memory that permits the entire memory to be simultaneously set. 4. Multi-computer. It is a multiple CPU computer used for parallel processing, and each processor has their own separate memory, that is, no shared global memory. The communication and synchronization among processors is via message passing. These systems are also known as loosely coupled. 5. Multiprocessor. It is a shared memory multiple CPU used for parallel processing. Unlike multi-computer, multiprocessors are allowed to directly share main memory. These systems are also known as tightly coupled. 6. Parallel processor. It is also designed for parallel computing, in which many processors are employed for the concurrent manipulation of data to solve a grand challenging problem. 7. Pipeline processor. It is basically an example of an array processor in which a pipeline processor speeds up computations by breaking a complex function into sets of simpler and faster operations. One of the earliest and widely used classification schemes of computer organizations was proposed by Michael Flynn in 1966. This classification scheme, popularly known as FLYNN'S taxonomy, is classified into 4 classes based on multiplicity of instruction streams and data streams. The instruction stream refers to the sequence of instructions as performed by the machine, which can be single instruction stream or one sequence, or multiple instruction stream or many sequences. The data stream, singular or multiple, refers to the sequence of data that is manipulated by the instruction stream. Based on the possibilities of instructions and data streams, Flynn formulated the following classes of computers. 1. Single instruction single data stream, or SISD. It comprises a single processor connected to a single memory. SISD computer fetches its instructions consecutively and then fetches one data item at a time. SISD systems are sequential uniprocessor computers and are considered classic von Neumann machine. Some advances to the SISD machines have been implemented, such as pipelining. Although instructions may be pipelined, but only one instruction can be decoded per unit of time. Also, SISD systems can have multiple functional units under the control of a single control unit. Many standard computers, such as the DEC-VAX 11780 and IBM 36370 series, fall into this class. 2. Single instruction multiple data stream, SIMD. Such systems typically consist of a single control unit, multiple processors, multiple memory modules, and an interconnection network. The control unit fetches instruction from memory, decodes it, and then executes it itself, or transfer instruction to other processing elements. These processing elements operate synchronously to execute the same instruction but with their own data. Processor arrays or pipeline processes, vector processes, array processes, and associative processes fall under this category. Examples of SIMD machines are ELIAC 4 and the massively parallel processing computers. 3. Multiple instruction single data stream MISD. Under this type of parallel computer, same data item is operated simultaneously by several instructions. This mode of operation is unrealistic and only few machines of this type have ever been built. 4. Multiple instructions, multiple data stream MIMD. In MIMD, all processing elements execute asynchronously on their own data. Hence, each processor follows its own instructions or multiple instruction stream and also fetches its own data on which it operates multiple data streams. MIMD architectures are used in computer-aided design or computer-aided manufacturing, simulation, and modeling. MIMD machines can be of shared memory or tightly coupled, or distributed memory or loosely coupled categories. Many computer systems fall under this category, including BBN Butterfly, the CM, and the Cosmic Cube. That brings us to the end of section. Thank you and see you in the following section.